Okay, and we're back. Some minor technical difficulties with the audio there. That was a Zoom problem. I was trying to maximize the screen space with Basil. But yeah, we got Basil on here again, and today we're going to talk about memory safety, programming languages, C, C++, and Rust. So Basil, you want to kick it off?
Sure. Um, so in the same vein of picking at poorly designed things, it's time to pick at non-memory safe programming languages. Because everybody that's ever used a computer or cell phone or any device that uses, modern technology has experienced the, oh, my program crashed, oh, it disappeared, oh, it's doing this weird thing, or it displayed something odd, or crashed a desktop, the usual. But beyond just those experiences that you see, um, there are the very critical vulnerabilities that occur for the same reasons, that are caused by memory unsafety. And that is basically the programming language that they're using, typically C and C++. C is ubiquitous across all devices. It's one of the oldest programming languages and the most widespread. It's in embedded devices, things like routers, switches. It's in your cell phone. It makes up the core code for kernels like Windows kernel, Linux kernel, Mac OS kernel. Um, and it is the thing that hackers typically hack. Those memory vulnerabilities include things like buffer overflow, which is like you put in your password to a program, and the password's only supposed to be a max of 100 characters. But the hacker goes, and what if I put 10,000 characters in there? What happens? And then buffer overflow results when obviously the extra 9,900 characters have to go somewhere. So they overflow the buffer. And if you're particularly nefarious person, you can actually put executable code at the end of that buffer overflow. And through a series of trial and error, you can find out where that executable code goes. And then you can pad it out so that that executable code will get put into what's called executable memory space. And that is run. That code isn't just read, it is actually executed. And that's how you get into various programs. But the buffer overflows are just one of a series of types of errors that can occur when handling computer memory. Not talking about storage like disks and RAM. And since um, it's something that every program has to do, it has to store information somewhere and all of that. If that memory is not handled properly, well, you get things like buffer overflow errors, stack smashing. You get dangling pointers and all kinds of fun stuff. And the resulting mayhem or nefarious exploits result from that. So this is being slowly phased out as best as we can for programming. The invention of languages like Rust and Google's Golang, they try to address this by adding safety mechanisms to to deal with the memory like it should be dealt with. Um, freeing the memory after the program uses that memory and making sure it's clear, or preventing things like dangling pointers and buffer overflows. So, but the problem is with that is these languages are new, and there is millions of lines of code that are written in other languages, C, C++, whatever else. You pick a language, there aren't many memory safe languages. So what do you do? Your entire infrastructure has these errors riddled throughout it, and there's no other way to deal with them other than simply rewrite those programs in another language that does actually deal with that. C++ has, unlike C, has some what's called garbage collection, but it doesn't actually do something like what Rust does. If you make a memory error in Rust, you can't even compile the program. Whereas in C or C++, you could probably compile it, and it would be who knows how long before you discover that that error is there. Um, so this is a extremely important topic when talking about computer security, just because C is ubiquitous. The Linux kernel is almost entirely written in C. There's assembly here and there, but those are the two languages. Same thing with every other operating system out there, except for like BOS, which was written in C++, and that's a that's a nightmare in of itself. Um, but that's something we have to address going forward as our infrastructure grows. We can't just continue to use these languages or these techniques for programming due to these flaws, because these bugs are never going to go away. And as a little bit of a stat, 70% of bugs, critical vulnerabilities, are memory related. Poor memory handling, or even if you're a good programmer, there's still plenty of situations in which memory can be exploited. And that's across the board. Microsoft, Google analyzed their Chrome code from the 2015 branch, and they found they had 912 memory errors and or 912 vulnerabilities, and of those, about 638 of them were memory related. So this is basically how hackers get most of your information, or how they break and exploit servers. If they know that there is a known vulnerability, there's tools out there like Metasploit that you can simply lock and load this vulnerability with an exploit into this thing and send it at a server, and then just get, if it's not patched, you just get access. That's what they use for penetration testing, Metasploit and something like Kali Linux. But that's speaks to the design issue of the whole thing. We've opted to program things in Rust and scripting things in Perl. Perl is not it's not the absolute best programming language, but there's a lot more security in it than some other languages. But Rust is the core that we want to work with moving forward. All of the significant code, all of our back end stuff that has to have ironclad security is going to be written in Rust to prevent all of those errors from the ground up.
Yeah, and also, I know we talked about wrapping the C++ for the Unreal 5 engine with Rust layer, and so that should definitely, help resolve some of those memory safety issues. Do you want to speak about that a little bit, or?
Yeah, basically you have to sandbox the Unreal Engine and all the parts of it that will handle anything sensitive in Rust, and any of the other stuff that you can do in pure Rust should be done. And that's our approach. Um, since there aren't any game engines to support our 3D spatial environment the way we'd want, written in Rust, we kind of have to sandbox it. But the entirety of the back end uh, will be written in Rust and Perl, and separated away from as many programs as we can eliminate from all the virtual appliances will be just gotten rid of. Everything really needs to be rewritten in Rust or some similar language for the memory safety. And Linux has actually taken steps to incorporate Rust into the kernel. It's not something they typically do. Um, if you ever listen to Linus Torvalds talk about incorporating C++ into the Linux kernel, he said that it lasted about a week, and then they abandoned their attempts because of the C++ garbage collection overhead was too much, among other things. It caused all kinds of kernel panics and problems with actually having a stable system. But so far, they've made a lot of inroads with using Rust. Since Rust doesn't use garbage collection, the techniques that they use to handle memory are built into the program itself and the way that it assembles the Rust code into assembly language. So it's lightning fast compared to other languages because it has no garbage collection overhead. Because if you're dealing with memory and you want to clear up, okay, I just used the variable x, and variable x has 512,000 stored in it, but I'm done with variable x. What do I do? I can't just continue to um, stick things in that space. I have to do something with it. So garbage collection typically goes along and cleans the memory, removes these things, and frees it up for use for other variables later on in the program. But that requires processing power and it requires memory, funny enough, that um, to eliminate those, or to go through and actually do that in a program. And that adds significant amounts of overhead to a program, especially the larger and more complicated a program is, or if you're the Linux kernel developers, it just makes your life makes your life a living hell. Um, so when we actually run the client will all of the Unreal code will be sandboxed and checked with Rust, and all of the other back-end connection, encryption, um, communications protocols will all be handled through Rust directly and not uh, through the actual Unreal program. The Unreal engine only handles displaying the graphical environment and handling anything that's handed to it from the Rust backend code, so that, hey, I need my photo, a photo of my father. I'm looking through my family album, and I want to pull that up. Well, then that comes to the Unreal Engine encrypted and is only handed off in an unencrypted state, or encrypted to the C++ side of things from the Rust backend. So only little bits of information that could potentially be stolen are actually handed to the vulnerable part that is the Unreal Engine itself. Because it's C++, and from my understanding, it's also Epic's own version of C++. Like they developed a branch of it. I haven't had a chance to do a deep dive into the specifics of it, but um, it's still C++ and it's still vulnerable to a bunch of things. So that's why we want to wrap the back end, or wrap the program and all of the vulnerable code with Rust to handle whatever needs to be handled in a secure way and not in a haphazard way.
Yeah, exactly. And it also, I think, it's going to easily protect the Unreal 5 blueprint system because that sort
Mm-hmm.
of goes hand in hand with the C++ aspect of things. And that's what Jacob, our front end lead programmer, has been working on. And he's going to join us with a video next week. We're going to talk about like the 3D spatial itself, how we're not a metaverse, you know,
Mm.
all that kind of fun stuff. I guess, do you want to talk more like about, um, I guess, some of the current problems with C++ or?
Well, I don't know. I've kind of, in a nutshell, covered all of that. But I mean, in general, it's not just C++. I don't want to single it out. C and C++ are just extremely ubiquitous in programming. That and most languages are based on C or C++. Even Rust. Rust is based on C and C++. Um, but if you design from C and you don't take memory safety into account, then you inherit all the vulnerabilities C or C++ has. So um, I think C sharp, Objective C, um, mm, they all have the same problems. It just has to it boils down to when you compile a program, um, what what are you doing with your memory? What are you doing with all of these different things, and how you put it together? Because the difference in Rust, the language itself has these characteristics, but the real magic of Rust is what they do when they compile the human readable code into assembly language. And that's where they're able to beat out a lot of other languages because they don't have the garbage collection and all that other stuff. Their executables are somewhat larger to accommodate that, but it's built right into it from the get go. And that's really the only way to do something like that. You don't go and build a house and start with the foundation and then go, after you finish the roof, go, man, I really shouldn't have used that terrible mortar for my foundation because then, 6 months later, your house falls down because the mortar cracks and the foundation sinks and falls apart and your house is gone. And that's sort of the situation we have with C. That's why cyber attacks are just as ubiquitous as the language itself. And now that there are more people online than there ever have been, there's also more vulnerabilities being exposed daily. Um, so I don't know if I pick C plus plus or C specifically to point at it. It's just it was never considered when it was designed. And I think that was a different world. You got to think in the 70s, 60s, and 70s when you had I mean, there are older languages, but in the 60s and 70s when you had the emergence of languages like C, um, the network around the world was very limited and was very much restricted to mostly technical use. It wasn't like the World Wide Web, and that environment wasn't as conducive to allowing the rapid dissemination of vulnerabilities once they're found. Nowadays you can go on the dark web and you can buy vulnerabilities. You can find people selling 0-day exploits. I mean, it's pretty common because those flaws have always been there, but it's only now that we've heaped so much weight on it. It's like your house with the foundation. Once you heap enough weight on that foundation, the little cracks that you couldn't see become big cracks that you can see. And then it's too late. Your house has already fallen in on itself. So that's unfortunately the state of affairs with our programming. And the only reasonable approach is to start over and keep these things in mind. Take the lessons that should have been learned years ago from these things and move forward with it instead of heaping more weight on already breaking down infrastructure. But,
Yeah, exactly. And I think it's interesting how Linux is going to be using Rust. Google has been using what their own sort of version
Go
of
or
Rust,
Golang.
Golang, yes. And so I think they all see the writing on the wall, and they realize that we need to move to a safer language. So, do you want to speak more on the benefits of the Rust language itself?
Um, well, Rust is fast, almost as fast as C. Um, and C's one of the reasons C is ubiquitous is because of its flexibility, its speed, and also the ease of deploying assembly. Because you can do assembly from C, just adding it into the program itself. You have to do a few things, but um, that's what's made it ubiquitous. And Rust has all of those features, but it has the memory safety on top of that, and that allows you um, to check, like I said, if a Rust program, if you violate some condition of its memory safety, trying to access a variable that you don't have access to, and so on and so forth, it just will not compile. And trust me, I've run into that learning Rust. Lots of things didn't compile that I had to figure out. Oh yeah, variables have ownership in Rust. That's another big feature, and it's a really amazing thing when you know how to use it correctly. Um, if if one function is using a variable and you want to um, hand that variable to another function so that that function can do something to it and they hand it back, you can pass a reference to it. You can what's called borrowing. You can borrow that, and you can do borrowing and read only, or you can write to it. But that gives it an extreme amount of precision for controlling how memory is used in the actual human readable program, aside from just what comes out in assembly. And Rust is also built to be cross platform from the get go. So you can compile things as easily in Linux or Windows or Mac OS or whatever, FreeBSD. You just go on forever. Wherever they have a compiler for it, just like C, you can compile it. So I think that gives it many of the advantages C has without the drawbacks. Uh, so I think that's one of the ways forward.
Yeah, for sure. I mean, it's. I'm definitely glad that you discovered the whole Rust language, and I know Basil's been talking about this for several years now. Pretty much, I don't know if you discovered it immediately as to when it came out, or when you found out about it, but
Yeah, I've kind of been following it since it first came out. Um, it hasn't really gotten any adoption, and it hadn't gotten any adoption at the time. It's starting to gain adoption now. Apparently, Stanford has classes on Rust. When I was looking through some articles, I came across my search showed Stanford had a course for Rust. Um, but the I've always been a sort of, I guess you call it, paranoid, even though it's not really paranoia when the NSAs can get into any computer they want because they have all the zero-day exploits. Um, but it's one of those things when you have a problem, and I've known about the problem with memory with C and C++. I learned C. That's one of my first languages. Um, but at the time, Rust didn't exist, and that was really the only thing. C, C++ you could learn, and Linux you can, any Linux system, you basically have the GCC compiler, and you write code and compile it. Um, but I see the adoption of Rust as a big step forward for computer security in general. Um, we just need to start taking that um, and just starting with devices from the ground up. The firmware, the embedded firmware should be written in Rust, because I'm pretty sure Rust can do the same thing that C does with assembly. They can also use C code directly in something called the foreign function interface. They can use C code directly and run it in unsafe mode. So you can even, contain the code that you're running that's going to be unsafe. Stuff like potentially using, drivers. Most of your drivers are written in assembly in C. Um, so you could use Rust to run the low level stuff that you need to run and not have to worry so much because Rust can actually catch it in the event that it does something it shouldn't do. Um, but that that's relatively new still. I think Rust is 2018 when it first came out, 2016. I'm not sure which.
Yeah, it seems like it's been around for, just for a little bit. It's been around for sure. I noticed even on LinkedIn when I was trying to find people to join our team, just trying to find people that did the Rust language, that seems to be difficult. And it seems more people that I've found when searching up people that program with Rust, they generally seem to be over in Europe. And I don't know what the reason is for that. I don't know if you have any insight on that kind of stuff, but it just seemed interesting to me that more of the people that I would find, were European and not here in the U.S. So I don't know if it's just because, people in the U.S. are so, already dug into C, C++, or web-based tech, right? I don't know. Maybe that's what the problem is. I really don't know.
I would say there's a lot of inertia just due to the fact that there's so much code already written in it. Um, oh, and it came out in 2010. I was wrong. It's 2010. So it's 12 years old now, um, which is not very old in programming language terms, considering the was it we had a COVID showed us we had the vulnerability in the unemployment system, and was that written in Pascal, I think, or no, COBOL. COBOL. It was written in COBOL, and there just weren't any COBOL programmers, and COBOL is like 60 years old. 63. It appeared in 1959. So, you know, that's uh that's a little bit of a time for computer programming. I
Oh yeah,
think they should have they should have abandoned COBOL a while ago.
yeah. I'm surprised they still, use that kind of stuff. Like you were talking about Pascal. I used Quick Pascal, way back in the '90s. My grandpa at the time had taught me how to program with it, and
Mm-hmm.
now I probably wouldn't know how to do any of it because I haven't done it in 20 plus 20 plus years, 25 years, whatever it's been. But yeah, it's just interesting how people get stuck in their ways and they stick with stuff that they already know instead of branching out, learning new languages that solves a lot of these problems, that you have
Mm-hmm.
mentioned. So I really think we sort of need to bring more awareness, to the community at large to get them to basically sign up with new or try out new languages like Rust or newer languages like Rust to see that they won't have to have their memory vulnerabilities and all that. So, do you have any more you want to talk about on the programming side of things?
Um, you just said something, and it reminded me of something that I forgot. Um, there was something I wanted to say. Oh, just in regard to computer technology, I think the takeaway from all of this, aside from or including all the stuff we talked about before and will talk about, um, is a lack of foresight. Um, Computers and computer technology have changed so rapidly beyond anything in human history. Um, it was thousands of years that we were just flint knapping and making basic fires. We didn't have any real advancement in that time. But in the past 70 years or so, we've managed to go from computers that ran on vacuum tubes and had literal bugs. That's where the term bugs come from, is because the vacuum tubes glowed and they attracted things like moths, and they had to debug the computers by cleaning out the dead bodies of the bugs. Um, to now we have smartphones, and in that space of time, that's unprecedented in human history. It's the fastest advancement of anything. So the takeaway, I think, is stop, take a look down the road, and spend some time thinking about where that road is going and what's going to be obstacles in the way before we commit anything to, write it in stone. Is it could change. It could change drastically. It could change in such a way that is unforeseeable. I mean, good case in point. The end of silicon is coming. Silicon chips are coming to an end, mostly due to the difficulty in producing them, but also electronics are reaching some fundamental physical limits. And there's been, for years, I've followed research on optical computing systems, the sort of stuff that Star Trek uses, like optical circuitry. And those do exist and are being advanced, but what is the world going to look like when you have optical computers that use mostly optical circuitry and use very little in the way of electrical circuitry? That's going to change things dramatically, and not just at a oh, it's different to work on. Um, the speed of light makes those circuits much faster, and also light circuits or optical circuits are basically immune to electromagnetic pulses because they operate differently. You don't have um, conductors to absorb that magnetic field and then burn out because it's all optical pathways. So I think we should take a step back, all of us as human beings on this planet, and ask ourselves, what is coming in the next 100 years? What messes are we going to make for ourselves because we didn't bother to think about our foundation that we built before we built the roof and stacked tens of thousands of pounds inside our house that then falls down?
Yeah, it's definitely a good analogy to think about, especially for current programmers or even future programmers, right? Because like in Michigan itself, it seems like there are so many different organizations that are not really talking about this stuff. Instead, they keep pushing like the web technology. They're like, oh yeah, I went to a JavaScript boot camp, or I went to web-based boot camp and stuff like that. But they're not really. I don't really see many boot camps, like in particular for Rust, for example, right? Like or C++ even, or any of these different things. It just seems like people get stuck in their ways. They don't think about changing, and then when stuff hits the fan, that's where they're at. They get stuck with it, so they don't have any way to fix it. But yeah, we're definitely gonna have I think some more videos on here. I know next week we want to talk about, like I said, the 3D spatial with Jacob and Basil and myself, and we might do another video today, but we'll definitely see. So, do you have anything else to add?
Mm-hmm.
Okay. Well, yeah, this is Rob Atkins and
Basil Miracle.
And yeah, thanks for joining us again, and we'll see you next time.
See you later.